In this video, we'll look into the solution of exercise 1 basic level questions from trigonometric functions. To solve these questions, you should have basic understanding about trigonometric ratios, reciprocal identities, and fundamental trigonometric identities as shown on the screen. Now let us start with the exercise. The first question is secant power 4 x minus secant square x is equal to tan power 4x plus tan square x. We have to solve this. For that, from this given, if we take secant squared x as common, the secant power 4 is nothing but secant square x whole square. Take secant square x as common, then that leaves secant square x of is another secant square x from the first term minus here we have 1. So we know the identity 1 plus tan square x is equal to secant square x. Here if we rearrange this, what happens? Take 1 to the other side. That makes tan square x is equal to secant square x minus 1. So in place of this, we can substitute tan square x. So here we will have secant square x into tan square x. Now in place of secant square, we will just substitute 1 plus tan square. That leaves 1 plus tan square x into tan square x. Now tan square x into 1 is tan square. And then here we have tan square into tan square, that is tan power 4x. So this is nothing but the RHS we have here. Now let us look into the next question. This is nothing but like a power 6 plus b power 6, which can be written as a square whole cube plus b square whole cube. From a cube plus b cube is equal to a plus b whole cube minus 3 in ab into a plus b. This is the formula we are going to use here. So this sine power 6s is now like sine square x whole power 3 plus cos square x whole power 3. So in place of a, we have sine square x, and in place of b, it's cos square x. Let's substitute those. That makes a plus b whole cube means sine square x plus cos square x whole cube minus, in place of a, it is sine square x, and in place of b, it is cos square x. Again, sine square x plus cos square x. We know the identity that sine square x plus cos square x is equal to 1. Here and here, if we substitute 1 cube is 1 minus 3 into sine square x into cos square x into 1. Means we can write it like 3 sine square x cos square x. This is nothing but the RHS that we have here. Coming to the next question. Here, we know that as per the reciprocal identities, cosec is nothing but 1 by sine. We'll write this. 1 by sine x minus sine x. We have braces here. And sec x is, secant is 1 by cos. Minus cos x. And here tan is sine by cos. And again we have cot, which is nothing but cos by sine. Now here if we take the LCM, it becomes 1 minus sine square x by sine x. Here LCM is cos, so 1 minus cos square x by cos x. And in this the LCM is cos x sine x. So we'll write that sine x. So it will become sine square x plus cos square x. Now from the identity sine square x plus cos square x is equal to 1, this can be written as 1. Whereas this 1 minus sine square x will become cos square x upon sine x. 1 minus cos square will become sine square x upon cos x. And this is 1. So we'll keep it as 1, and then we have sine x cos x. Now if we multiply all the numerators, it becomes sine square x into cos square x. And in denominator also, if we multiply everything, it becomes sine square x into cos square x. That is like 1 here. Coming to the next question, also we'll write this in terms of sine or cosecant, sec in terms of cos, like that we will convert this. So it will be like 1 by sine x into 1 by cos x minus 1. And cot x is nothing but cos by sine. And cos will keep it as it is. Now here if we take the LCM, it becomes 1 by sine x into 1 minus cos x upon cos x minus, here we'll retain this as this cos by sine x into 1. Now in these two terms, if we observe this 1 minus cos x is there in both the terms, and even upon sine x is also there, we'll take those two out by sine x. So from the first term, we'll have 1 upon cos x. And from the second term, we'll have only cos x. These two are taken out. So minus cos x. Again, if we take LCM here, this becomes 1 minus cos square x upon cos x. This into 1 minus cos x, the sin x upon x. Now 1 minus cos square x is nothing but sin square x. So when we substitute this with sin square x, in this place we will have sin square x. Then we can cancel this sin x and one of this sin x. So sin x, we will have the sin x remaining, cancelling out. Sin x upon cos x is nothing but tan x. So this is like 1 minus cos x into tan x. Now tan x, if we take it in, 1 into tan x is tan x. And this simplification, like we have now cos x into tan x. This cos x, tan x can be written as sin x upon cos x. So what happens, this cos x and cos x will get cancelled and the remaining would be sin x. So tan x minus sin x. So this is nothing but the RHS we have. So here if we write secant as 1 upon cos and cosecant as 1 upon sine. On taking LCM, this becomes sin x minus cos x upon cos x into sin x. Okay, so in this place, we can substitute this value. Let's do that. Numerator we have 1 minus sin x into cos x upon the cos x as this. Then in place of this, we are writing this. That is sin x minus cos x upon cos x into sin x. Now for this second thing, in numerator sin square x minus cos square x, it is like a square minus b square, which can be written as a plus b into a minus b. So that portion can be written as a. In place of a, we have sin, and in place of b, we have cos. A plus b into a minus b. And in denominator, it is like a cube plus b cube, which can be written as a plus b into a square minus ab plus b square, whereas a is sin x and b is cos x. So we'll write it down here. So it is like sin x plus cos x into a square, that is sin square x, minus ab, that is sin x cos x, plus b square, that is cos square x. Now here if we see, we can cancel these two, numerator and denominator, and then we will have these two. And here again, the cos x and cos x can be cancelled. If we can take this sin x to the numerator, as it is like in denominator we have a fraction, we can write the reciprocal of that. So we'll make it as 1 minus sin x cos x into this sin x here upon sin x minus cos x into, here in numerator we have sin x minus cos x, and in denominator if we see, this sin square x plus cos square x can be written as 1. So it is 1 minus sin x x. Now here we see that this sin x minus cos x and sin x minus cos x can be cancelled out. And here again 1 minus sin x cos x and 1 minus sin x cos x will get cancelled out, and that leaves sin x as the answer. This is the RHS. Coming to the next question. So this cot x can be written as 1 upon tan x. We'll write that here. We have tan x upon 1 minus 1 upon tan x less 1 upon tan x into 1 by 1 minus tan x. Now take the LCM here and then tan x to the numerator. That makes tan square x upon tan x minus 1 plus 1 by tan x will be there, and in denominator if we take minus 1 out, it becomes minus 1 upon tan x minus 1. Now if we take the LCM here, this LCM would be tan x into tan x minus 1. So now for the first term, tan x into tan square x will be tan cube x. Here it is 1 into minus 1, that is minus 1. The numerator is nothing but in form of a cube minus b cube, and that can be written as a minus b into a square plus ab plus b square. So considering that in place of a we have tan x, so it is tan x minus 1 into tan square x plus tan x plus 1 upon tan x into tan x minus 1. From numerator and denominator, we can cancel out this tan x minus 1. And here tan square x plus 1 can be written as secant square x. And then we have tan x as it is. From the denominator, we have tan x. If we separate the terms, it will be like secant square x upon tan x plus tan x upon tan x is 1. The secant square x upon tan x is sin x. So we'll write this to be secant square x into cos x upon sin x plus 1. So it is again secant x upon sin x. Secant x upon sin x plus 1. Because here 1 secant x into cos x will become 1. So there will be only 1 secant x remaining. So 1 by sin x is nothing but cosecant x. So secant x into cosecant x plus 1. This is nothing but the RHS. Coming to the next question here. In the numerator, we have it in the form of a cube plus b cube. So that can be written like a cube plus b cube can be written as a plus b into a square minus ab plus b square. Similarly, a cube minus b cube can be written as a minus b into a square plus ab plus b square. This is these two formulas we will use here. Now, in place of a, it is sin x, and in place of b, we have cos x. So, this will become sin x less cos x into sin square x minus sin x cos x plus cos square x upon the denominator as it is sin x plus cos x. For the second term, less, it is a cube minus b cube. So, sin x minus cos x into sin square x plus sin x cos x plus cos square x upon sin x minus cos x. Denominator as it is we are adding here. So these two terms will get cancelled. Even here these two terms will get cancelled. Sin square x plus cos square x can be written as 1 and the remaining term minus sin x cos x. Even from here, sin square x plus cos square x is 1. Here plus we have and we'll write it as is. So 1 and then the remaining thing, that is sin x cos x. Now here it is minus sin x plus sin x cos x. So these two will get cancelled out. You have 1 plus 1, that is nothing but 2. This is the RHS we have. Coming to the next question. Here this is like a plus b whole square. So we will expand that as per a square plus 2ab plus b square. This can be written as secant square x secant square y plus tan square x tan square y plus 2ab, that is plus 2 secant x secant y tan x tan y. And the second term also we will expand. This is minus of, again, secant square x tan square y plus tan square x secant square y plus 2 secant x tan y tan x secant y. Now here if we take this first term and the first term here, we can take secant square x as common. Now taking secant square x as common, we'll have secant square y, the minus here, so it is minus tan square y. Now from the second term here and the second term here, we can take tan square x as common. So that leaves tan square y minus secant square y. Now if we observe these two, this one and the last one here is 2 secant x secant y tan x tan y. Here also we have 2 secant x secant y tan x tan y. They are same but separated with a minus sign, so they will get cancelled out. From the identity we know that 1 plus tan square theta is equal to secant square theta. If we rearrange this, take the tan square to the other side, this is like secant square minus tan square equal to 1. Or if we take the other way, it can also be written as tan square minus secant square. We are taking minus 1 common, so is equal to minus 1. In place of this secant square y minus tan square y, we will use this identity wherein we can keep 1. So this thing will become secant square x. Here it is tan square y minus secant square y. So it's in this way. So we have to keep minus 1 less tan square x into minus 1. So this can be written as secant square x minus tan square x. So it is again like this, secant square theta minus tan square theta, which is equal to 1. So this can be written as 1 and that's the required RHS. Now the next sum. Here first we'll take the left hand side and we'll rationalize the denominator. To rationalize, we have to multiply with 1 less sin x, both numerator and denominator. So the LHS will get modified like cos x into 1 plus sin x upon 1 minus sin x into 1 plus sin x. So the denominator is like a minus b into a plus b, which is nothing but a square minus b square. So it's cos x into 1 plus sin x upon a minus b, a square minus b square. So this 1 minus sin square x is nothing but cos square x. So here cos x and one of this cos square x will get cancelled out. We'll be left with 1 plus sin x upon cos x. So this is what we got after simplifying the left hand side. Now we'll simplify the right hand side. Right hand side also we'll try to rationalize. On checking the denominator, we can rationalize with 1 plus cos x plus sin x. When we do that, the right hand side will become, we are multiplying with 1 plus cos x plus sin x, both numerator and denominator. So this will become whole square upon, this is like a, 1 plus cos x, and sin x is like b, again a square minus b square, that is 1 plus cos x whole square, a square minus b square, that is sin square x. We'll expand the numerator, it is like a plus b plus c whole square, and we know that to be a square plus b square plus c square plus 2ab plus 2bc plus 2ca. We'll use that. So a square plus b square plus c square plus 2ab, that is 2 cos x, plus 2bc, that is 2 cos x sin x, plus 2ca, that is 2 sin x. In denominator, we'll expand using a plus b whole square here. That makes 1 plus cos square x plus 2 cos x, and the next term minus sin square x as it is. In numerator, if we see cos square x plus sin square x is equal to 1. So in place of these two, we'll substitute 1. So 1 plus 1 is 2. And the remaining terms, we'll write it down as it is. 2 sin x cos x plus 2 sin x. Now in the denominator, if we see 1 minus sin square x is nothing but cos square x. In place of these two, we'll write cos square x. And this cos square x plus cos square x is 2 cos square x. So we'll write 2 cos square x, and the left term is 2 cos x. In numerator, if we consider this, we can take 2 as common. 2 out. 1 plus cos x will be here from these two terms. If we take 2 out, it would be like 1 plus cos x. And the remaining two terms, we can take sin x out. So when we take sin x out, it becomes plus sin x of, here the remaining is cos x. And in the last term, we don't have anything. So it means plus 1. In denominator also, we can take from the denominator 2 cos x out. So it is 2 cos x of, from the first term, we will have 1 cos x remaining, the second term plus 1. Now check this, we can cancel the 2 and 2. In the numerator, we have 2 terms from which we can take 1 plus cos x out. From this term, we'll have only 1. So 1 plus, in the second term, we'll have sin x. So 1 plus sin x upon, in the denominator, we have here cos x into 1 plus cos x. This 1 plus cos x, 1 plus cos x will get cancelled out. We are left with 1 plus sin x upon cos x after simplifying the right hand side. This is same as what we have got here. These two are same. So both left hand side and right hand side, they are equal. Hence proved. In this video, we have seen how to prove few of the identities like shown on the screen.